Welcome everybody. I'm starting this series on linear algebra. Now it is important to understand that the subject linear algebra has exploded because of the serious advancements in the branch of computer sciences. Now without computers in today's world, it is totally a challenge to move from point A to point B, because this subject, or I would say this area, has literally taken over all known branches, or I would say all known fields. And to have a grasp of this field, you have to have knowledge in linear algebra. And they say that knowledge is power and information is wealth. So you will have to get yourself trained in this subject, linear algebra. And having mentioned that, let me move on. Now in this particular course, there are a few important concepts you will have to know. So the first and foremost concept that I will be starting is what is called as a linear combination. I'm going to explain to you why do we need this and its significance. Now suppose you have variables like x1, x2, x3, etc. all the way up to xn. Then the linear combination of these variables, say x1, x2, etc., xn, as the form a1 times x1 plus a2 times x2 plus a3 times x3 plus etc. plus an times xn, where a1, a2, a3, etc. an are element of real numbers and are called the combination coefficient. Okay, now as I mentioned to you, the question comes, why do we need this? For that, we have to go to the next definition. So let me name it as definition 1. Now I can give you an example for this. A popular example can be one of this pattern: 1 over 5 times x, positive 2 times y, negative z, where the coefficients 1, 2, 1 over 5 are element of real numbers. So this is an example for this. Okay, having mentioned you this definition, let me move on to the next definition. So this definition will emphasize the reason why I have given you this definition. So let me give you this. What is a linear equation? Now a linear equation in variables x1, x2, etc. xn is of the form a1 times x1 plus a2 times x2 plus a3 times x3 plus etc. plus an times xn is equal to some quantity d, where this d is an element of real numbers. Okay, now as I mentioned to you, I gave you this all important definition for linear combination, and now the definition for linear equation. Now, why is this important? Now, let me give you this classic illustration. Okay, this classic illustration of an organization. Now, this organization wants to hit a profit of, say, 1 million USD. They want to reach this profit of 1 million USD for the current year. Now, to get this, they will have to definitely need people, right? Not just people, they need qualified people. The qualified people are the people who will ensure that the company gets this quantity of profit for the year. Now, for a company to make this kind of profit, there is something called as teamwork. To achieve anything in life, you need to have a team. Now, without this team, you cannot achieve the goal. Now, what will the company do? The company has got professional X1, professional X2, professional X3, professional X4. Okay? So, the company has to utilize these professionals to achieve 1 million USD. So, this is the target. What is the target? 1 million USD is the target. Now, having got this team, what is the company going to do? How is the company going to organize the professionals which I have just given you? X1, X2, X3, X4. So what is the company going to do? The company is going to take in the professionals X1, X2, X3 and X4 and going to give them different responsibilities. Now, to the first company, or I would say to the first variable X1, the company is going to allocate a resource, say organizing events. Okay, so let me give a capital E, organizing events. Now, to the second person, the company is going to give speaking at the events. To the third person, the company is going to give meeting the required clients. Now, to the final person is going to be the contract signing with the influential people or the people who are interested in doing the business. Okay, now we see there are three quantities here: E, S, M and C. Now this E, S, M and C is what is going to be called as the combination coefficients. So you can increase the values of these or you can decrease the values of these. How much of resources you are allocating to these, you can have that. But having mentioned that, the variables X1, X2, X3, X4, these are also changeable. You can replace, or I would say in the real scenario, the positions of X1 and X4 can be interchanged. The position of X4 and X2 can be interchanged. The position of X2 and X4 can also, X2 and X3 can also be interchanged. So we call these things as the combination. All of the companies in the world, they are looking for this right combination of their team. And once they achieve this, they will not do anything to disturb the balance, because this right combination leads them to what is the required profit. Now this concept is applicable not only in managerial positions, not only in organizations, but right from algorithm designs to the management of huge systems. This concept is not going to be altered at all. What is going to be altered is the system, right? This system which we see here, this system and the coefficients will be altered. So what is your duty? Your duty is to gain a mastery of how exactly you can manipulate these with the knowledge of linear algebra. So that is the objective of this lesson. Okay, having given you this, we are always looking into equation because we need the balance. Now let me move on. This is definition number 3. Now I have just given you one equation, but an organization will have several teams, right? So there comes what is called as the system of linear equations. So how will the system look? The system will be in this fashion. One, it's a constant, right? This will be the form of the system. Plus etc. a1 comma n times xn is equal to, say, sum d1. And the next one is going to be a2 comma 1 x1 plus a2 comma 2 x2 plus etc. a2 comma n times xn is equal to d2. So we move on like this, and finally we will reach a system which is of this fashion: am comma 1 times x1 plus am comma 2 times x2 plus etc. plus am comma n times xn is equal to some value, say d1 we have taken as d1 d2, and this will be dm. Okay, now we are interested in getting the solution for this, right? After all, we want to produce such systems on and on and on. Now we are not just interested in producing a system, we are producing an effective system. We need this. Now effective system is a system that delivers. Okay, so now the all important part in this system is what is called as a solution, right? So I'm going to be talking about the solutions of a linear system. That's going to be my next thing. Okay, so let me start off like this. If a1 x1 plus a2 x2 etc. plus say an xn is equal to d be the given linear equation, okay, such that you got a1 a2 etc. an element of R and d element of R, then the solution s1 comma s2 etc. xn will be the solution of, say, I'm going to take it as 1, solution of 1 if a1 times s1 plus a2 times s2 plus etc. a3 times or an plus an times sn is equal to d. Okay, so in place of x1 x2 etc. xn, if I were to substitute s1 s2 s3, then the combination should produce me the right hand side. Now this is for one equation. Okay, so now if I were to take this for the system of linear equation, how will the definition be? So this is also a definition, so I'm going to take it as definition 4. Now definition 5. for a linear system of equation, I'm going to write this down like this. For a linear system of equations, S1, S2, etc. xn will be the solution. If this is the most important thing, if S1, S2, etc. Sn satisfies all of the equations. Okay, S1, S2, S3, etc. Sn should satisfy all of these equations. Okay, so this is the introductory class for linear algebra. Now, having given you this, let's head on to problem solving. The next thing is going to be problem solving. So let me move on to the next page. Now I'm going to teach you what is called as the Gauss method. You either call it as Gauss method or Gauss elimination. Okay, so these two words or these two terminologies are okay or accepted. Now we are given a question: 1 over 4 times x positive y negative z is equal to 0. X positive 4 times y positive 2 times z is equal to 12. And 2 times x negative 3 times y negative z is equal to 3. Now you got equation 1, equation 2 and equation 3. And you are expected to find the value of x, the value of y, the value of z. Now look at this in this fashion, a practical way. Now imagine you have an organization. Okay, this is some organization, say A. As I mentioned to you, this organization wants to make a profit of 1 million USD. Okay, now as I mentioned to you also before, we need people. Okay, we need people X, we need people Y, we need people Z. Now the organization will given the resources. Now the constants that you see here are the resources given to the people. So the organization is willing to give these values. These are the values: 1 over 4 times 1 negative, there is a value there. Now these are all different sections in which x, y, z have to work, right? In one part of the project, x has got this value 1 over 4, but in another project x has got a value 1. In the other project x gets this value 2. So there are different values given to the same x, and that is going on for y, and that is also case for z. Now before bringing in the people x, y and z, the company actually does something. The company actually carries out a process, what is called as the interview. And in the interview, the company looks for the skills that people have. In this case, the skills that X has, the skills that Y has, the skills that Z has. Okay? And the company which gets the right skill or right amount of skill in each of these variables, X, Y and Z, that will be the company which moves up. You follow what I'm trying to say? So the equation that you are seeing is not just an equation, but a representation of a real life scenario that every successful organization has to carry out. Okay, so having mentioned that thing, let me move on. Now what I'm going to do, I'm going to find the right hit for X, Y, Z, and that is called a solution. Solution means what? Solution is nothing but the key that opens the lock. Okay, that's why we call it as a key. And solution also is a better word, and both these terminologies, they go hand in hand. Okay, given you this practical implication or practical application of this equation, Gauss or the system, Gauss has given us the technique. So how do we do that? What I'm going to do, I'm going to call each of these systems as rho 1, rho 2 and rho 3. Now foremost, what I'm going to do, I'm going to multiply 4 with rho 1 and I'm going to write it as rho 1. I don't want this 1 over 4. Multiply throughout. That would give me x positive 4 times y, negative 4 times z is equal to 0. Now rewrite the rho 2. X positive 4y positive 2 times z is equal to 12. And then rho 3, 2x negative 3y negative z is equal to 3. Now the most important point you have to know in solving this is never utilize row changes. Once you have picked the row. Now what do you mean by this? That means if I'm going to be utilizing this row 1 for changing row 2, row 3, I cannot change the row 1's utilization and replace it with row 2. So what I mean is, I'm going to demonstrate this. I'm going to take row 1 to change row 2. After you have done that, do not use row 3, or I would say do not use the changed row 2 to change row 3. Don't do that. If you're going to be choosing row 1 to perform all the manipulations, that row always stays there as the row that you have to use to change row 2 and the other rows, no matter you have 10 rows. Okay, so that is the all important part you have to know. Okay, I mentioned this. Now what I wish to do is I will have to manipulate this row 2. What I mean by manipulation is I want to get rid of a variable. That's the most important thing. Now when you are given a system of equation, you have to remove the variables. You remove the variables, you remove the variables, you remove the variables, and then you end up with one variable, and that variable will lead you to the first solution. So that's the idea. Okay, now having given you the idea, let me utilize row 1 to change row 2. So how do I do that? I multiply by negative 1 with row 1 and then I add it with row 2. So when you multiply, you get negative x with positive of negative 1. That's going to be negative 4 times y, and then negative 1 with 4 will give me positive is equal to 0. Now I'm going to rewrite this. This is going to be negative x and then negative 4y positive 4 times z is equal to 0. Okay, actually you don't need to write this, but I just want to show you what is happening. Now you have to add it with row 2. What is row 2? Row 2 is x positive 4 times y positive 2 times z is equal to 12. Now negative positive, you add them, they get cancelled. You add them, they get cancelled. And in this case you add them, you get 6z is equal to 12. Therefore z is equal to 12 divided by 6, which means 2. So z is equal to 2. You have already found that value. Z is equal to 2. Now move on. Use row 1 to change row 3. So I would be moving on here. Negative 2 times of row 1 added with row 3. So what is my negative 2 times of row 1? So let me write that down. Okay, so negative 2 times of row 1 is x positive 4y negative 4z is equal to 0. This is going to give me negative 2 times x negative 8 times y positive 8 times z is equal to 0, and my row 3 is 2 times x negative 3 times y negative z is equal to 3. You add it. This is going to be negative 11y and this is going to give me positive 7z is equal to, you add it, you get 3. So this is what you've got. Okay, so now having got this, I'm going to name this as 4 and I'm going to name it as 5. Now what I'm going to do next is use z is equal to 2 in 5 we get. So what do we get? Negative 11 times y, positive 7 times of 2 is equal to 3, negative 11 times y, positive 14 is equal to 3. Move this, you get negative 11 times y is equal to 3, negative 14. That is going to give you negative 11 times y. Therefore, y is equal to 11 over 11, which means y is equal to 1. Okay, so this is my 6. Now, go back to the row which we have. Okay, you can substitute, you know y, you know z, and then you substitute in row 3. Okay, use, what I'm going to use z is equal to 2 and y is equal to 1 in 3 we get. So what is 3? 2 times of x, negative 3 times of 1, negative 2 is equal to 3. This is 2 times of x, negative 3, negative 2 is equal to 3. 2 times of x, negative 5 is equal to 3. Move this to the other side, you get 2 times of x is 3, positive 5, which means 2 times of x is equal to 8. So x is equal to 2. 8 divides 2, which is equal to 4. Therefore, x is equal to 4. Now, you got x, y, z. Next, you have to check. You got to check. So, I'm going to use x is equal to 4, y is equal to 1, and z is equal to 2 in 1. So, what is the first one? 1 times 4 of x is 4, plus y is 1, negative z is 2. This should give me the right hand side. So 4 divides 1. So 1 added with 1 is 2. 2 negative 2 is equal to 0. This means left hand side is equal to right hand side. Therefore, the solution is x is equal to 4, y is equal to 1, and z is equal to 2. So that completes the result. Okay. So that is the end of this beautiful question. Application of Gauss's elimination. We will do more such questions. Thank you everybody. Please like, share and subscribe.